Namaste. Welcome back to my video. If you are seeing the first time of our channel, please subscribe to our channel. Let's enter into our video. Hi. From the last class, we started the new chapter, Classification of Elements and Periodicity in Properties. In the last class, we discussed about how different scientists classified the elements by their ideas and thoughts. Daubernier triads, Newlands of the octaves, Mendeleev's periodic law. The finally and widely accepted model is Mendeleev's periodic table and law. So we discussed about the Mendeleev's periodic law, how he given periodic table, all of this in the last video. Now we are entering into the main and actual subject information in this chapter is modern periodic table. Modern periodic table. Before entering into the information of modern periodic table and law, here you must know one thing. We must bear in mind that when Mendeleev developed his periodic table, chemists knew nothing about the internal structure of atom. However, the beginning of the 20th century witnessed profound developments in theories about subatomic particles. In 1913, the English physicist Henry Moseley observed regularities in the characteristics X-ray spectra of elements. What he given means a plate of root V. Here V is the frequency of X-rays that was emitted against atomic number Z. Gave a straight line, not the plot of root V, E versus atomic mass. He thereby showed that the atomic number is more fundamental property of an element than its atomic mass. Okay? And do you understand? That means he thereby showed that the atomic number is a more fundamental property for the elements, for the property of an element than its atomic mass. All the scientists, all the classification of elements is done by atomic mass. So here what he discovered means the property for the element is fundamentally property of an element is atomic number, not a atomic mass. Mendeleev's periodic law was therefore accordingly modified. This is known as the modern periodic law. Let's enter what is the modern periodic law. The physical and chemical properties of elements. Physical as well as chemical properties of elements are periodic functions of their atomic numbers, not with their atomic weights. Okay, atomic masses. You may recall that the atomic number is equal to the number of protons, that means nuclear charge, or the number of electrons in a neutral atom. It is then easy to visualize the significance at quantum numbers and electronic configuration in periodicity of elements. So here I am given again the law, modern periodic law, the properties of the elements or the periodic function to their atomic numbers. So and valence electronic configuration also. For this I discuss it later in another video. So about the modern periodic table. Modern periodic table is also called as long form periodic table. You are seeing the colorful modern periodic table of the elements. Here in the boxes, in every boxes there is a symbol and the number is the atomic number, which is equal to the number of protons. Well, a modern version The so-called long form of the periodic table of the elements is the most convenient and widely used. The horizontal rows, so these are the horizontal rows, are called periods, and the vertical columns are called groups. Elements having similar outer electronic configuration in their atoms are arranged in vertical columns referred to as groups. According to the recommendation of IUPAC, the groups are numbered to 1 to 18. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's it. These are the 18 groups. So the periods are here. The periods are, sorry, these are the 18 groups and the periods are 7 periods. The period number corresponds to the highest principal quantum number n of the elements in the period. So, shortest period is the first period, having only two elements, hydrogen and helium. And the second period contains 8 elements. Third period contains also 8 elements. Fourth period contains 18 elements. Fifth period contains 18 elements. Sixth period contains 32 elements. Seventh period it is incomplete. So why I am saying sixth period contains 32 elements means, so here you are seeing a two double periods below the periodic table. I will tell later why these elements kept below the periodic table. So finally, that's it all about the modern periodic table, about the groups and periods. Along with naturally occurring elements, there are man-made elements also. Some elements are radioactive elements. The elements from atomic number 58 to 71 are kept in the below the periodic table separately. So in the before I said that why these elements are kept below the periodic table. The elements from atomic number 90 to 103 are kept below the periodic table separately. The undiscovered elements can be represented by using IUPAC nomenclature, International Union of Pure and Applied Chemistry, that is in which the undiscovered elements, that means this group. There are some blanks. What this means for new discovery elements, they given space. Now, what the doubt means? Do you have a doubt? Yes. The naming of new elements had been done by who? The new elements are discovered from time to time. The for naming of the elements had been who done? So that information was given by IUPAC. Nomenclature of elements. The naming of the new elements had been traditionally the privilege of the discoverer, and the suggested name was ratified by the IUPAC. In recent years, this has led to some controversy. The new elements with very high atomic numbers are so unstable that only minute quantities, sometimes only a few atoms of them, are obtained. Their synthesis and characterization therefore require highly sophisticated, costly equipment and laboratory. Such work is carried out with competitive spirit only in some laboratories in the world. Scientists, before collecting the reliable data on the new element, at times get tempted to claim for its discovery. So I think you try to understand. For better understanding, I give an example. For example, both American and Soviet scientists claimed credit for discovering element 104, a 104 element. Both American and Soviet scientists, American and Soviet scientist. The Americans named it Rutherfordium, whereas Soviets named it Kerkatovium. To avoid such problems, that means they given Rutherfordium, they given Kerkatovium. So how IUPAC nomenclature of element with the atomic number less than 100. Okay, here digit, name, abbreviation. If it is 0, name nil, abbreviation form N. 1, un, U. 2, bi, B. 3, tri, T. 4, quad, Q. 5, pent, P. 6, hex, H. 7, sept, S. 8, oct, O. 9, N, E. So that's it. For example, if it is 104, that means 104, un, nil, quad, dot em. If it is 105, un, nil, pent, dot em. If it is 106, un, nil, hex, dot im. So if it is 114, un, quad, dot em. 115, un, pent, dot em. That means UUP, that is abbreviated forms. These are what the IUPAC names for elements with Z above, that means atomic number above 100. So these are less than 100. Well, this is all about today's information about the modern periodic table. This is what only some introduction about the periodic table. In the next videos, we studied about how the elements are again classified into different types, that means blocks, series, transition, representative, all of this in next videos. So this is all about today's video.